Okay, so on this one, we're wanting to add these two fractions. So how do we add these two fractions? Well, to add fractions, you got to have common denominators. You got to have the denominators be exactly the same. Notice these two denominators are really very, very similar. They're just opposite order, huh? So is there a way that we could just like turn one of them around to make it match the other? Yes, there is. But what's going to do that is you got to multiply by -1. What am I talking about? Well, I don't know if you've ever thought about, so the order, if you add two things, 2 plus 6, 6 plus 2, it doesn't matter at all, right? It's 8 either way. It's 8 either way. Doesn't matter at all. So, so if these were added, my point is, if these were added, I would just turn one of them around and not even give it a second thought. It's all the same. Order doesn't matter. But if they're subtracted, that makes a difference, doesn't it? Right? You see that if you subtract with the smaller one first, you get -4, and the other way it's +4. So the order of subtracting does matter. Makes a difference, doesn't it? I can't just flip it around and pretend I haven't changed something. I have. And we can't be changing the problem willy-nilly. So well, then what do? You multiply top and bottom by -1, because notice the answer is only different by a sign. When you switch 2 minus 6 and 6 minus 2, the answer doesn't come out to be some totally different number. It just comes out to be the opposite sign, negative or positive, huh? So that kind of clues us in that really it's just a sign issue. So I'm going to come in here and multiply top and bottom by -1. So that's what you do to switch the order of subtracted items. Multiply top and bottom of the fraction by -1. Okay, so, and also it doesn't really matter which one you turn around. You can turn around this one over here on the left. That'd be fine. It does, just turn one of them around. It doesn't really. I'm just going to turn the other one around. Okay, so this one's 20y 9x minus 10y. The other one, when you multiply by -1 times that's just -18x. What happens here? Well, this -1 is going to go there and there, right? It has to distribute through the parentheses. So, okay, so what? So then you get minus 10y plus 9x. See how that negative multiplied both of those? Changing both signs. It hit the regular 10y to become -10y, and it hit the -9x to become plus 10x. And now, this is the other thing I want to see if you realize. If you have something like 2 minus 6, do you realize that's the same thing as -6 plus 2? That's still -4, right? In other words, I know this is a little confusing because these are similar but slightly different. Basically, you can switch the order on anything you want as long as you take their signs with them. Am I making any sense? Let me say that again. You can change the order really anytime you want, as long as you take their signs with them. What do I mean their signs with them? That negative sign right here on the 6, that's really his sign. I know we think of it as between, sitting in the middle of the 2 and the 6, but not really. It really belongs to the 6. Signs belong to who they're in front of. Well, what does the 2 have? He has nothing in front, which means positive, right? So the 2 really has his own invisible plus sign, and the 6 has his own negative sign. And so when you move them around, It's fine to do that as long as you take their signs with them. Nothing will change, right? Negative 6 plus 2 is still negative 4, just like 2 minus 6 was. Okay, so right now I can switch the order on these guys. And that's what I'm going to do. Change order. Take signs with them. So then I'll say, okay. Come on down here and make, oops, wrong road there. Okay. So 9x minus 10y. Just making some sense over here. Oops, a little far now. Okay, so we're going to add these together. And now we can combine them. We have 20y minus 18x. All right, you seeing what happened there? We just put those in, plus the negative 18x is just minus 18x. So we turned around, excuse me, we turned around, basically we multiplied top and bottom by negative 1. And that changed these signs, and then we could switch them, switch the order. And now they're exactly the same, aren't they? See that? And then once the denominators are the same, you can combine them into one denominator. One fraction. Right? And last step, in fact, here, let me bring this down, probably better. So step 1 over here, let me write these out as steps. Step 1, multiply top and bottom. Well, let's put this is step 1 right here. Here's step number 1. Number 1 is right here. Just switch the order, multiply top by fraction by noon, then change order. So that was all step number 1. And then coming on down here to step number 2. Now the denominators are the same, combined to one fraction. Combined to one fraction. And we just say plus a negative 18x is just minus 18x. Okay, and then the last step, remember what we always do once we have one fraction. Step 3, reduce, simplify, reduce, whatever you want to say. Simplify. Now, how do we simplify? Can I just like cancel x with x, and 9 goes into 18 2 times, and 10 goes into 20 2 times, and cancel? No, no, you cannot. You cannot cancel added, subtracted items. You cannot cancel added, subtracted items. Instead, factor. Right? So how do we factor? Well, if you look at 20 and 18, what goes into both of them? 2, huh? They're both divisible by 2. So take out a 2. And that'll leave 10y minus 9x. We good there? Because that 2 times 10y, go back to 20y, and 2 times 9x, go back to 18x. Okay. Now what? Now we have this and this again. Look at that. This problem just keeps going and going with this kind of thing. Those are like the same thing, but they're the opposite order. What do they do? Well, there. I'm just going to cancel them because it's going to be -1. Let me prove it to you. What if you had 4? What if you had those kind of things? What would that be? -2/2, which is -1. See if you have two things in the opposite order. So let's see, top and bottom subtracted in the opposite order. Cancels to equal -1. So in other words, if you have 3, let me give you an example. What if I had 8 minus 3 over 3 minus 8? What would that be? 5 over -5. See how they all just equal -1? See what I'm saying? So 10y minus 9x, 9x minus, they cancel. My point is these guys are gonna cancel to equal -1. So finally, this problem, it's 2 becomes -1. And so that's just -2. And we're done. That was a crazy problem. All right, let me recap what just happened there. There was a lot of fancy little switching order steps here. From the beginning, we noticed these two, to add two fractions, you got to have same denominators. We noticed that they were the same, except they were the opposite order. And so to switch the order of subtracted items, multiply top and bottom by -1. So we multiply top and bottom by -1, made the top -18, it distributed on the bottom to get this. And then we can change the order, taking the signs with them. I put the plus 9x in the front, put the -10y in the back. Then the two denominators were the same, exactly the same. So we could combine into one fraction. Put them into one fraction. And then step 3 is simplify. Cannot cancel out items, instead factor. So we factored the top, took out a 2. We notice they were both divisible by 2. Took out a 2. And then we got again this top and bottom being the same, except for switch the order. So we could just cancel them, and it's -1, because we saw some examples of that. And so that's 2 times -1. It's just all -2. All that other stuff is canceled out. So the answer is -2. There we go.